Okay, so here's your review video. Just so you know, this video is counting for multiple classes, honors and CP, so I may have assigned certain problems to certain classes. However, I talk about all of the problems in this video. Everything in here can be done without a calculator, but obviously if I've told you you could use a calculator, use it to your advantage. And the last thing I'll tell you is at the very beginning, I've gone through and I've taken screenshots of all of the solutions. You are welcome and should check your answers and then watch the video parts that you need. You need to try to work all problems first before watching this video. Lastly, you need to have work shown for every problem on your packet that you do. I don't want to see you just copying down what I've done. That's not going to help you study. All right, so here are the answers to the first page. And the bottom of the first page. Make sure that you're checking the answer on the final number line. The entire second page. The top of the third page. The bottom of the third page. The top of the fourth page. The bottom of the fourth page, and the back. And I may have miscounted because I feel like there were supposed to be 6 pages. So go ahead and fast forward to whatever sections you need to watch and listen to the solutions for. So here's how this review video is going to work. I am going to work out every single problem on this video. You do not have to watch them all straight through. At the end of each page, I will zoom out so you can check the entire page. So you should already be finished with each section before you watch this video. So what you should do is fast forward until you see me zoomed out to show you the entire page. And then you can go through and check each individual answer, or how I worked the problem, rather, if you got one wrong. All right, so I'm going to dive right into this first section. I'm actually going to answer question 5 first. The two things, this is an actual question that I have put on a test before. The two things that make inequalities different is that the variable has to end on the left, and when you multiply or divide by a negative, the sign, the inequality symbol flips around. All right, so question 1, if I'm going to work that one out. The first thing I need to do is distribute. That's going to give me x plus 7. X plus 42 is less than or equal to 90. And then I need to combine like terms, or at least that's what I would do next. So that's going to give me 8x plus 42 is less than or equal to 90. Subtract 42 from both sides. 8x is less than or equal to, let's see, 48. Divide by 8, which is going to give me x is less than or equal to 6. So I know this less than or equal to symbol means that I need to make a closed circle on 6 because of the equal to, and shade to the left because we're at less than. All right, if we look at question 2, again, distributing is going to be my first step. 6x plus 36 is less than 36x plus 36. Subtract my x's, that's going to give me negative 24x plus 36 is less than 36. Subtract 36 from both sides, negative 24x is less than 0. If I divide by negative 24, that's going to give me x is less than, if I divide by a negative, remember, symbol's got to flip around, that's going to be x is greater than 0. Now, I think some of you may not have subtracted this 36x in the beginning. You may have subtracted 6x instead. So if you did that, you would have gotten 36 is less than 30x plus 36. And then if we subtract 36 from both sides, that's 30x is greater than 0, divide by 30. That gives me 0 is less than x, but remember, if x is, like when you finish, x has to be on the left, so when you read this backwards, you get x is greater than 0, which is exactly what I got the first time. So greater than is going to be a strictly open circle, and then greater than is going to go to the right. Okay, question 3. I'm going to distribute my negative. Now, this is kind of a trick here, or it might trick you. When you distribute a negative, that's not going to flip the symbol around. It's when you multiply or divide both sides by negative that's going to change the symbol. So this is going to be negative 8x plus 64 is greater than 25 minus 8x. If you notice, the negative 8x's are going to cancel on both sides, so I'm left with 64 is greater than 25. Remember, anytime the variables go away, that means you're going to have a special case, and so you just need to determine if what is written here is true or false. So is 64 greater than 25? Well, yes it is. That's true. So this is an example of all real numbers. And because it's all real numbers, we're going to shade the entire number line because we want to identify every single number on the number line as a possible solution. All right, question 4. You all know I hate fractions. The first thing I'm going to do is try to get rid of them. So I'm going to multiply everything by 36. All right, that's going to cancel on this side. 36 times 13 is going to get pretty large, but I know that 36 divided by 6, if I do that part first, is 6. So 6 times 13 is going to give me, I believe, 78. And then if I multiply here, that's times 12, so 48k is less than 25. If I combine like terms, that's going to give me 30k is less than 25. All right, I'm going to divide both sides by 30. Remember, it's okay to get fractions. We just want to make sure we simplify them. So this is going to be k is less than 5 over 6. And 5/6 is just a little bit less than 1. So I'm going to make an open circle here, a little bit less than 1. And then less than means I need to shade to the left. So I'm going to make sure I shade this way. All right, so there's our section on solving inequalities. You can go ahead and check all those answers now. All right, let's move on to this section on compound inequalities and their graphs. So remember our rules for and or. And means both have to happen, and generally means that they're going to go together, or means only one thing has to be true at a time. So let's dive into these. On this first one, we're just going to solve that out. Add 7 to both sides. That's negative 4x is greater than or equal to 36. Divide by negative 4 means my symbol is going to flip around. So x is going to be less than or equal to negative 12. Negative 3x, subtract 3 from both sides is going to give me 6. Divide by negative 3, got to flip the symbol around. That's going to give me x is greater than negative 2. And I'm looking at or here, which means I don't need them to overlap. Just wherever they land, they land. So or is greater than or equal to negative 2, open and to the right. Less than or equal to negative 12 is going to be closed. Where am I? Negative 12, and to the left. All right, question 7. Again, go ahead and solve that out. Add 10 to both sides. 10x is less than or equal to negative 100. Divide by 10. X is less than or equal to negative 10. Subtract 6 from both sides. 10x is greater than or equal to 60. Divide by 10. X is greater than or equal to 6. So I'm going to do closed on 6 right here and to the right. And for less than or equal to negative 10, closed on negative 10 and to the left. And since this is or, it's okay that they're going opposite directions. I don't care about where they're overlapping. If you're still doing the dummy graph, which is a good thing for you to be doing, you're doing like this. Well, I guess I should make that closed and to the left, closed and to the right. And when you consider your 3 sections, you've got true because there's at least one graph there, false in the middle, and true on the end. All right, that's how you know how to graph that section. All right, question 8. If I solve this out, subtract 1, 4x is less than 8, divide by 4, x is less than 2, and, which means I'm going to be looking for an overlap this time. Subtract 10 from both sides, x is greater than or equal to 7. All right, so in my kind of dummy graph, x is less than 2 is going to be open on 2 and to the left. X is greater than or equal to 7. Oh, negative 7, I should have subtracted that better, is going to be closed on negative 7 and to the right. And I'm looking for the section where they both exist. So where they're both existing here is going to be closed, this middle section, and then open on 2. All right, question 9. Subtract 4 from both sides. 8m is less than or equal to negative 64. Divide by 8. M is less than or equal to negative 8. Notice the symbol is not flipping around right here because I'm not dividing by a negative number. I'm going to be dividing by positive 8 here. right? Or add 8 to both sides, rather. So that's going to give me negative 8m is less than or equal to negative 16. This time, divide by a negative. My symbol is going to flip around, so that's going to give me m is greater than or equal to positive 2. Or means they're probably going to be going opposite directions. So greater than or equal to 2, closed and to the right. Less than or equal to negative 8 is going to be closed and to the left. All right, question 10. We're getting into one of the trickier ones. Multiply by 2 on both sides. It's going to be x is less than or equal to 0, because 0 times 2 is 0. And divide by negative 6. X is we're going to flip that around. Less than or equal to negative divided by negative is positive. So, and I'm looking for an overlap. And if you go ahead and graph these, I'm going to have negative 0 and less than, and negative 2 and less than. So notice they're not going towards each other anymore, but I still want the overlap. So the overlapping section is from this point of negative 2 and to the left. So this is one of those weird and cases where I'm not actually getting a set that's going towards one another. All right, question 11. Remember, if you have a compound inequality written together, that means instinctively that you're just going to have an and you have to break it apart into 2 equations. Now, I know that there is another way to do this all as one, but I kind of want to show you as 2 just so you see what's weird about this problem. So negative 4 is less than or equal to n minus 4. I'm going to add 4 to both sides. Excuse me, that's going to give me 0 less than or equal to n, and I know I have to turn it around to graph it. N is greater than or equal to 0. And my other equation is n minus 4. It's less than negative 9. Add 4 to both sides. It's going to give me n is less than negative 5. So now when I go to graph these, and means I'm looking for where they both are, the overlap. So greater than or equal to 0, less than negative 5. And you should see these are not overlapping anywhere. So what you want to do, since there is no overlap, this is going to be an example of no solution. And we're going to keep the number line completely blank. So you don't want to actually put anything on there as your final answer. The number line is just blank in and of itself. All right, so here are the solutions for this set. So hopefully you're checking. If you get any wrong, rewind and find the section where I talk about how I got these solutions. All right, so in this section, we're talking about writing functions. You really just need to make sure that you read the question and pay attention to the directions that are being asked. So question 12 says write a function. That means we're going to write f of x to represent the situation, and make sure you define the variable, which is what we say x stands for. So it says admission fee is $9. Each ride, that's one of those keywords, costs $1.75. So that means I'm going to write $1.75x plus 9. Or you could write 9 plus 175x. Either way is going to be considered correct. You want to say what x stands for, which is the number of rides, because it says each ride. All right, there are 12 total rides of the carnival. Provide an appropriate domain and range. So we want to address, first of all, is this discrete or continuous? And this is an example of discrete. You can only go on a single number of rides. You can't go on like half of a ride. So since this is discrete, we're going to list our domain and range separately. So domain is going to be our number of rides. So you could go on 0 rides. Like to me at a carnival, you could actually enter the carnival and not go on any rides. You could just be there to spend time with your friends. Or you could go on 1 ride or 2 rides, or I'm going to get lazy here, all the way up to 12 rides, right? We could count like that. And then our range is how much you're going to spend. So if you go on 0 rides, you'll spend $9. If you go on 1 ride, you're going to spend, $10.75. And then so on and so forth. And then you just need to figure out how much you're going to spend for 12 rides. So you're kind of plugging 12 in right here. You might use your calculator to figure that out, or just work that out outside of the table function. And when I do that, I get that you're going to spend $30 maximum on rides. And then what do the domain and range represent in context? Well, domain, remember, domain are my x values. And I already said that my x values were the number of rides, right? We already said that. So you're really you just need to know that domain and x go together. So then my range, these range values that I'm getting here, those are my y values. When we listed those, we were talking about how much money you spent. So that's money spent or used, or however you want to say that. All right. This next set of questions, a plumber charges $50 per hour plus $30 for the call. So here, $50 per hour, that's a rate, $30 for the call. So my function, f of x, is going to equal $50 per hour plus $30 for the call. And x stands for the number of hours because we said per hour. And then what does he charge for 3 hours of work? So we're going to write our answer in function notation. So to figure that out, I'm going to find f of 3, which just means we plug in 50 times 3 plus 30 equals 150 plus 30, which is 180. So my final answer, we're going to write f of 3 equals 180. That's just a way to kind of say, when I plugged in 3, I got 180. And so to write a sentence, when it says a sentence in context, you don't want to say, when I plug in 3, I get 180. You want to talk about what does that mean. So it means for 3 hours of work, this is the same as interpreting. For 3 hours of work, you will charge, or be charged rather, or maybe we'll say he will charge because we're talking about the plumber. He will charge $180. All right, last question. A sanitation company, that's like a garbage truck service, right? Charges $4 per bag. That's a rate word, plus a $10 weekly fee. So write a function to represent the situation. So we're going to say function means to do f of x equals define the 4x, that's my rate, plus a $10 weekly fee. Define the variable x equals the number of bags. If you aren't sure on how I'm defining the variable every time, I'm just looking at whatever word comes after the rate word. So since this says per, bag is going to be what my variable stands for. And somehow I forgot to hit play when I was working out the rest of this problem. So notice here I did 14 bags of garbage, so I just substituted 14 in for x, worked that out, and wrote my answer in function notation, f of 14 equals 66. And then writing a sentence that says, you just want to make sure in your sentence that you explain both numbers, what the 14 represents and the 66. And that says, the sentence that you can't read says, for 14 bags of garbage, the company will charge $66. Okay, so on this section, I know that I assigned different problems for different classes. So you just need to watch the ones that I told your class to focus on, the ones that I said that you would need to know for tomorrow. And remember, I'm pretty sure I said that this section was non-calculator. It's just depending on whatever I told your class. So make sure that you know how to do that for whatever you were asked to do that for. All right, so question 21. H of -7 means I just want to replace the variable with -7 and find its value. So I'm going to have -3 times -7 squared plus 4. That's going to give me -3. -7 squared, that's how you read that, is -7 times -7, which we all know is positive 49 plus 4. When I do 49 times 3, I'm getting -147 plus 4, which is going to give me -143 here. All right, so you really just want to make sure that you pay attention to how this whole sign situation is playing out in this problem. All right, question 22, this one should be pretty simple. G of 10 just means to plug 10 in for the variable, so I'm going to have -3 times 10 minus 1. This is how I'm evaluating G of 10. That's going to give me -30 minus 1, which is -31, so G of 10 is -31. Notice I'm not doing anything to this other side to like work it out. I'm only solving the right-hand side of the equation. I'm not doing anything on that left-hand side. It's literally just a section for notation to remind myself what it was I had been plugging in the whole time. Okay, so really similarly on question 23, we're going to be plugging in -6 this time, so 3 times -6 plus 2 is my h of -6. So it's going to equal -18 plus 2, and negative 18 plus 2 is negative 16. So h of negative 6 is negative 16. All right, last question. This one kind of has a trick to it. Notice the variable is in 2 locations. So when I replace this value of negative 8, I need to replace it twice. So that's going to give me g of negative 8 equals negative 8 squared plus 2 times negative 8. Notice I always put parentheses when I plug in because this is the value of n squared. So negative 8 squared is positive 64 minus 16, which should give me 48. So that's going to be g of negative 8 equals 48. Let's see, so let's zoom out so you can check this section. All right, there's that top section. You can check and make sure you're right. I actually don't have the answers written very well on this first one. We should probably say h of negative 7 equals negative 143. All right, and then this bottom section. Determine if the graph is discrete or continuous, then graph the function using the given domain. So anytime we have a given domain, that's an example of discrete. So both of these are going to be discrete. So we just need to go ahead and graph them. Don't let the way number 25 is written kind of confuse you with that f of x. Remember, that's just another way to write y. So you could even rewrite this, y equals 3x minus 2. The first thing I'm going to do is go ahead and plot all my points. I'm going to start at negative 2. Rise 3, run 1, rise 3, run 1 to the right. And then I'm going to go down 3 and to the left 1, down 3 to the left 1. Now, I only want the points with these given domains. So I want to find the x value. Remember, domain means x. So the x value of negative 2 means I want the point that corresponds right here. I want the point that corresponds at 1 for an x value and at 4. And I don't want any of the other points. So I'm actually going to go back and erase those other points because I don't want them in my answer. So your final answer should just have 3 points given. All right, question 26. If we work this out, now notice this does not say y equals, so I need to fix that. And if I move the 2x over, it's going to be y equals negative 2x plus 12. So I'm going to start at 12, and I need to do a slope of negative 2 over 1. So I'm going to go down 2 to the right 1, down 2 to the right 1, down 2. All right, for these problems, I just continue them all the way through the graph. And then I'm going to go back and find those specific domains. So this says a domain of x equals 1, x equals 2, x equals 4, and x equals 6. And so I'm going to erase all those other points that don't apply. So that's going to be these are all gone. And I know that I'm on the right track because I'm left with 4 points in the end. Another thing you can do to check is to name your ordered pairs. Like this is 1, 10, 2, 8. And as long as you notice that all these x values are lining up with the x values that you were given, you know that you've done the right thing. So here are your answers for that section. All right, now I have noticed that I've left off a few things for these graphs. Notice that none of these equations are straight vertical or horizontal lines, so we are probably going to need to talk about that. I may add just a few quick examples to make sure you remember that before this is all said and done. All right, so question 18 here. This is slope-intercept, y equals mx plus b, so I'm going to start at 5 on the y-axis. Notice that this slope is 2 over 1, which normally would mean to rise 2 and run to the right 1. Notice I don't really have room to do that. Like I can kind of make a point off the graph, but it's not in an exact place. I do think this point is a good idea because it's going to keep you on track and make sure you count the rest of the slope the correct direction. So now we're going to go down 2 and to the left 1, down 2 to the left 1. And we're just going to keep that going through the graph. And then since this does not give me a domain, I want to connect it so that it's continuous. So make sure that you do connect all of these since they don't give you a specific domain. Question 19, you can solve this if you want to for y, but I think intercepts is an easier option, so I'm going to break it apart and give myself two options. Either 4x equals -4, which is going to give me an x-intercept of -1, so I'm going to plot that on the x-axis, or -y equals -4, so y is going to equal +4. So I'm going to plot that on the y-axis, and that's going to create my line when I connect them. All right, question 20. It would be really nice if this one was as simple as 19, but it isn't. I can't divide the 3 into the 10, so since I can't do that, I need to actually solve this out for y. So I'm going to, let me recopy my problem real quick, y equals 10. I'm going to subtract 3x from both sides. That's going to give me -2y equals -3x plus 10. Some of you write 10 minus 3x, and that's fine. It's whatever works for you. Divide every single thing by -2. And remember, negative divided by a negative here is going to give me a positive. So that's +3/2x. And then 10 divided by -2 is going to give me -5. So I'm going to start this line at -5 and just count a slope up 3/2, up 3/2, up 3/2. And I don't even have room to go down and to the left, so that's all I'm going to fit on the graph. All right, question 21. This one does do well for splitting for intercepts because everything's going to divide, so that's going to give me 6x equals 6, so an x-intercept of 1, so I'll go ahead and plot that one. And then 2y equals 6, or a y-intercept of 3, so I'll go ahead and plot it. Intercepts are so easy. And then I'm just going to connect my line. Probably use a better color. There we go. Connect my line, and I'm done. Question 22. Don't get tricked. Remember, this has an x and a y, so it's still going to be a diagonal line in some way. They're only completely vertical or horizontal if they don't have an x or maybe don't have a y. But if they have both, they have to be diagonal. So this is actually a +0, so I'm going to start at 0, 0. Down 2 to the right 1, go all the way through the graph, and then up 2 to the left 1, all the way through the graph. All right, question 23, we're going to start at +3. This one is already in slope-intercept form, which is easy. Remember, this right here, you have to either make it -2/5 or 2/-5. You have to put that negative in only one place. You can't put it on both of them. So I'm going to go down 2 into the right 5, or I can go up 2 into the left 5. And that's going to give me my line. All right, so there are the answers to your graphing questions. And let me actually go ahead and talk about those horizontal and vertical lines just so you have them for reference. Remember, anything that's like an x equals line can only touch the x-axis. So if I graph like x equals 5, that's going to go through the x-axis at 5. If I graph a line of y equals -3, that's going to go through the y-axis at -3. So make sure you are familiar with those as well, because those will be on your test tomorrow. All right, so there are your answers to check. Okay, and let's come down here and check the bottom. All right, discrete and continuous. Remember, discrete are separate points. Those are things that must be counted in whole numbers. Continuous, things that have got to be counted or that can be counted in fractional parts. So distance covered with respect to the number of minutes that have passed. I'm going to go ahead and say that this is something that is continuous because distance and time are both continuously measured. The number of pieces of laundry, so pieces of laundry over a period of time. So pieces of laundry, like you can't fold half a sock or half a shirt. Either you folded the shirt or you didn't fold the shirt. So this is going to be an example of discrete. And then the cost of gasoline based on the number of gallons pumped. If you've ever even watched the gasoline pump count, it's counting continuously. It doesn't, you don't have 1 gallon and then suddenly jump to 2 gallons and suddenly jump to 3, right? So this is another example of continuous. All right, as I told you in class, I really love these questions at the top. So some of them are just to kind of make you think. So this says, are all linear graphs functions? So everything that's a line, is it a function? Remember, functions have to pass that vertical line test where they can't touch a line more than once. So the answer here is no. Any line that is completely vertical is not going to be a function, because if you think about putting your pencil on that, it's going to touch an infinite number of times. So it's not a function. It is going to fail the vertical line test. Let's see. Test an infinite number of times. This is just the infinity symbol. You can write the word infinite out if you want to. All right, draw an example of a nonlinear graph that is still a function. So anything that your vertical line or your pencil test, would pass. So we can draw any type of squiggly line like this. No matter where I draw my vertical line, it's only going to cross once. So I know that that is still a function. You really just can't have anything that crosses like over itself. That's not going to be a function, because when you try to draw your vertical line, it's going to cross in more than one point. Create a mapping that is not a function. So this doesn't have to be hard. I can just put any set of numbers that I want to in here, 1, 2, 3, 4. Anything that's not a function is when one thing is going to two different values, right? Each input can only have one output. So this right here is going to fail because the 1 has two different, this would help if I spelled right, output values, which is not allowed. All right, question 5. So those are your function questions at the top. You may be asked to identify functions or not on your test, but if you can answer those 3, you're certainly ready for that part of your test. All right, question 5 and the question next to it are about intercepts. So if we look at these questions, name the intercept, x-intercept for the function below. So we already kind of did this on the graphing if you watch that section, but if not, I'll talk about that again here. Intercepts, you just want to split the equation into two options. So it's either 3x equals negative 18, which is going to give me x equals negative 6, and it says write it as ordered pairs, so that's negative 6, 0. Or the other option is negative 9y equals negative 18. Do not forget to keep this negative sign with the 9. Notice that it's attached, so it needs to go with it when you split it apart. Divide by negative 9, that's going to give me y equals positive 3, so my y-intercept is going to be 0, positive 3. All right, when are equations not good for intercepts? So anything that's in standard form, but that doesn't divide well. So an example of that might be, 2x plus 3y equals, let's see, 10. That would be a bad example for intercepts because the 3 is not going to divide into the 10. And it says, and solve it for y, because I wanted you to get practice in solving for y. So like in my equation, if I solve for y, subtract 2x from both sides, that's going to give me 3y equals 10 minus 2x, or negative 2x plus 10. Divide by 3, every single thing. So that's going to be y equals 10 over 3 minus 2 over 3x. So basically, it's going to end up messy. You should have at least one fraction if you're solving it that way. If you don't have a fraction, then your equation was probably not bad the first time, which is not okay. You want it to be bad because we said what was not good for intercepts. All right, so here are the answers for this first section. All right, let's check 7 and 8. Okay, remember x-intercepts are written in the format a number, comma 0. So you want the number to be in the x value of the ordered pair. Y-intercepts are 0, comma a number. Well, I guess I should have written that the way I said it, 0, comma a number. Solutions are just other points in the table. And then rate of change, we'll talk about that here in a second. All of these say to interpret, which means to write a sentence. So we want to make sure that we do both. So when we state the x-intercept, I see that is this point down here, 14, comma 0. And when we interpret, it's really easy just to use the headings on the table here. So this says after 14 hours, because that's what the 14 is there for, after 14 hours, the pool has 0 gallons left in it. And then the y-intercept is going to be 0, 10,080. So after 0 hours, or you can say at the beginning, after 0 hours, the pool has 10,080 gallons. Another solution is really just any other point on this set. So like if you pick the point 10, 2880, notice that all my sentences are looking the same, right? After 10 hours, the pool has 2880 left. So usually if you form your first sentence well, the rest of them can just fall into place like that. And this other solution, just know that there are, like in this table, there are 4 possible answers. You could have listed any one of those 4 pairs and written a sentence about it. All right, rate of change. Notice that this pool is draining, so the amount of water in the pool is going down over time. So you kind of can go ahead and start your sentence that way. The amount of water in the pool is decreasing at a rate of, okay, so notice that for rate of change, I want to say that I'm talking about a rate, and then just talk about how much the water is decreasing. And to me, I just picked the easiest place to count. So it's going down 1,440 for every 2 hours. And if you divide that out, which you always should when you interpret rate of change, that should give you 720. So it's decreasing at a rate of 720 gallons per hour. All right, in this last section, we can actually get more specific in the next unit, but really I just want you to be able to tell me what are the different types of slope. So question 12, this is a negative slope. Remember, if you write the word like slope or any word, your name on it, if the word angles down, that's going to be negative. If the word angles up, that's going to be positive. If we're going to go straight across, remember this is 0. Think about you're writing the word 0. So this is a 0 slope. If I go straight up, that's going to be a positive slope. Sorry, not straight up, but increasing. And then right here I've got what we call undefined, if it's straight up and down. All right, so those are your different types of slope. Last question, thank goodness. Am I right? All right. You can read how this problem works. So how long was she at the grocery store? This graph is actually marked with some given information, so we're just going to answer the different questions. Let's see, she starts at the grocery store here. That's what obviously what the G represents. And then notice that this whole time that her distance stays the same, she's going to be at the grocery store because she's not getting any closer to her house or further away. So that is from 15 minutes until 35 minutes. So we're going to say that she was at the grocery store for 20 minutes total. 15, if you want to take notes, 15 to 35 minutes was the time frame. What was her average rate of change between 35 and 55 minutes? So I'm just going to note kind of where she was at each of those. So at, let's see, at, what did I say, 35? At 35 minutes, she's here. At 55, she's down here. Now we're talking about average rate of change. So you really just want to think about, if I'm just thinking about those 2 points, not the fact that she might have gone faster or slower getting there. So she's going from 15 miles away from her house to 10 miles away from her house. So that's a rate of change of -5 miles over a period of 20 minutes. So we want to divide that out, which is going to be negative 0.25 or negative 1/4 of a mile per minute. Or you could say 1 mile every 4 minutes if you wanted to. And the question, why is that negative? So remember that this is the distance away from her house. So it must just be that when she goes to the hardware store is closer to her home, which is what you should have written here for why it's negative. The hardware store is closer to her home. All right, and then question 3 is a lot like question 1. How long is she at the hardware store? So to me, that just looks like a period of about 5 minutes. So I'm going to say 5 minutes. What was her average rate of change from the time she left the hardware store to the time she arrived at the auto parts store? Okay, so we want to think about this the same way that we did number 2. So if you've already watched number 2, you may want to pause and try to apply that to question number 4 before you check the answer. All right, so we're just going to notice that her distance is changing from her house 10 miles to, let's see, 20. And it's going to take from 55 minutes until 80 minutes to get there. So that is going to be an increase of, 10 miles for every, 25 minutes, because I'm going from 55 to 80, so 25 minutes. And we just want to simplify that, which is going to give me 4/10 of a mile, so 0.4 miles per minute. Is going to be the rate that it takes her to drive that distance. All right, and then domain and range. So remember domain and range, when we set this up, we're talking about, first of all, domain is talking about my x values. Range, oh, I don't know why I did that. Range is talking about my y values. And these first and last points we want to think about as the lowest possible x value and the highest possible x value. And the same for the domain and range. So thinking about your graph, you think about the lowest x value and the highest x value. My lowest x value is 0. That's where time is starting. And the highest x value here looks like it goes to 100. And then for range, my lowest x value is 0. And you don't want to look at the ending y value. You want to look at the highest y value. And the highest the distance ever gets is 20. All right, so there's your domain and range for this problem.